Hello everyone. In this lesson we're going to take a look at the periodic table and how it was developed. It was developed in the late 1800s by Dmitri Mendeleev, and he did it without any knowledge of atomic structure. All he could use were chemical properties. So Mendeleev listed the elements and put them into groups with similar properties. He wasn't the first person to do this. There were other scientists who were doing it at the time. He also noticed that some of the elements had periodic properties. Periodic simply means repeating, things that happen and then start over again. Like the moon always goes from new moon to new moon, and we go from crescent to quarter to gibbous to third quarter to waning crescent and start over, right? So periodic just means repeating. Now, Mendeleev was working with Dalton's model of the atom, so he didn't know anything about subatomic particles, but he did know about atomic mass, in that some elements were heavier than other elements. And he noticed when he arranged the elements by atomic mass, periodic patterns emerged. So that is a repeating pattern. So if he had his elements arranged by atomic mass, he noticed the first one would react with chlorine in a 1-to-1 ratio. Then you would get a 1-to-2 ratio with the next element, then a 1-to-3, 1-to-4, 1-to-3, 1-to-2, 1-to-1, and then none. So he would see all of those things happening in his with his elements, and he's like, okay, so that's a pattern that repeats. So the next time I see something that reacts in a 1-to-1 ratio with chlorine, I'm going to go ahead and start a new row on my table, because I'm starting a new period, I'm starting a new cycle. So when he did this, he showed the periodic nature of the elements. That's why it's called the periodic table, because properties repeat from row to row. He did have to remove or change, I guess not remove, but he had to move a couple of elements in order of atomic mass, because if he just went strictly by atomic mass, then the periodic properties did not fall where they should. They'd be out of order. So he had to flip a couple elements into different positions. And then the thing that made Mendeleev a genius at this was he did not assume that we already had discovered all of the elements. He assumed if there was a gap in his table, it wasn't because the pattern was broken, but because we hadn't found an element yet. And so he said, listen, we are going to find these other elements, and when we do, they'll have properties that fit right here. We will find an element that goes in this position on the periodic table, and these are the properties it will have. And actually it took a couple years, but several of the elements that he left blank spots for were actually found. And because they were found and had properties that Mendeleev predicted, his table is still in use today. Now, it did have to get changed up a little bit when we discovered protons, but what it did was it explained the flips in the table. It didn't actually change Mendeleev's observations. So once Rutherford discovered protons, Moseley took the table and ordered it by increasing atomic number rather than by atomic mass. And when you do that, the flips go away. Those were because of the neutrons. Remember, the number of neutrons changes to make the atom stable. And sometimes the number of neutrons is different than just strictly a 1-to-1 increase with atomic number. So sometimes you have something that has a lower atomic number but a higher atomic mass because it's got some extra neutrons in it. So the flips were there because the discrepancy caused by neutrons. Now we have this periodic table that shows the properties of elements being repetitive from one side to the other, arranged by atomic number. And once we have that, we're also going to see some other cool things like we saw with the orbitals, where electrons are going. So the discovery of the quantum of the model of the atom is why we don't just have continuous rows, but why we shifted the inner block down, right? So it shows us the first two columns, the S, the last 6 columns, the P, the D block, and the F block. So the shape of it is based off of the atomic or the quantum model of the atom, whereas the ordering of it and the groupings there are based off of the chemical properties and the periodicity that Mendeleev discovered. So periodic law just says that when elements are put in order by increasing atomic number, their properties repeat periodically. That statement is actually pretty powerful. And by just using the periodic table, we're able to predict how certain elements are going to behave. We're able to predict what kind of bonds they will form, how many bonds they will form, what we can do with them in chemical reactions. So remember, a period is a row, and across a row the properties change. The elements go from very reactive metals to non-metals to noble gases, but that happens in every single row. Columns will have similar properties because they have the same electron configuration, right? Anytime we're in group 1, we have our valence electron is a 1s1. Anytime we're in column 2, our valence electrons are 1s2. So we know based on electron configuration that they're going to have similar properties. On the periodic table, there are certain groups that you should be able to recognize. The main group elements, which are the S and P blocks, so first 2 columns, last 6 columns. The transition metals and intertransition metals, which are the D and F blocks. The metals, nonmetals, and metalloids, show you that in a second. Metals are generally on the left side of the table, nonmetals are on the right side of the table, and there is a zigzag line that separates the metals from the nonmetals. Those are called the metalloids or semimetallics. The alkali metals are group 1, that's column 1, that starts with hydrogen, except hydrogen is a nonmetal, so lithium, sodium, potassium, rubidium, cesium, and francium. The alkaline earth metals, which is group 2, second column, and then the halogens, group 17, and the noble gases, group 18. Those are 4 major groups on the periodic table that you should be able to recognize. Now, here, like I said, here's the periodic table. I said I'd tell you some more. So over here, group 1, alkaline metals, not hydrogen. Group 2, alkaline earth metals. The middle block, the D block here, is the transition metals. That includes the F block down here. Sometimes those are called the intertransition metals. The metals follow this zigzag line. So if you start here on boron and you trace down and just do this stair-step thing, then this zigzag line actually touches all of the metalloids, and then you have aluminum and polonium that are actually metals that touch that line. And then over here you have the non-metals. Last column over here is the noble gases, and then right here we have the halogens in column 17. So periodic table, there's lots of trends and things that we can look at that repeat from one side to the other. We are going to look at those in more detail in the rest of this chapter, but it's a very powerful tool for predicting how elements will behave.